Okay, now we're going to look at the linear differential equation. So when we have a sub n d to the n power of x over d sub t, this is the nth derivative with respect to t plus a sub n minus 1. And that a sub n can be also a function of t, not necessary to be a constant. This is d to the n minus 1 divided by d to the n minus 1. So I have to be careful where I put actually uh, the derivative. So this is n, and that's n minus 1. And actually, I don't need it for the denominator. The only thing I need is only for the numerator. I'm saying this is the nth degree. This is n minus 1 degree. And this continue until you reach some kind of a constant term with respect to t, but times x. So you can see that we're taking the derivative, and we have over here a function in term of t. Now, if e of t is equal to 0, then this will be considered a homogeneous equation. So then let's define again what we mean by homogeneous. Let's mean the function is equal to 0. So what we want to do now, we want to actually look at the different differential equation and how to solve it. And I want to use the method which is called integrated factor. So let me put the integrated factor right here and see how we can use it. And I want to say that first I want to look at what we call by the general form. So if we have dy over dx plus b of x times y, and that's equal g of x. This is the general form. And maybe somehow we will have what we call is initial condition. So if we have this situation, okay, now let me highlight the important thing for us, that the b of x and this one. And this number right here, I'm worried about that all the time. I want it to be 1. So if we have this, what we call is a first degree differential equation, then we're going to look at u of t, which is what we call is the integrated factor. And the formula for that is e times the integration of b of x dx. So let's go ahead and box this one and box this and have it in your formula sheet as one of the important item how to solve linear differential equation. Now, step 1, we will find what we mean by this. Step 2, we'll multiply the whole equation, the entire equation, by u of x, which is the integrated factor. The third equation we integrate and solve for y. Okay, let's see how we can handle the first example. So here's my example 1. Example 1, now we have that a dy over dx plus 2y, and that's equal e to the negative x. So we are going to start with the problem. We identify the function over here as b, and this is as your g. So now I'm really glad that number right here is 1. Therefore, I'm going to directly find my, let's go ahead and call it my integrated factor. It's the integration of, hold on, e to the integration of 2 dx, because that is my integration factor. Now, the minute we know what's our integration factor, we'll go ahead and integrate it. Now, how would we integrate this? Now, let's see how we will integrate this. We will go to, let me pause for a minute. I think people trying to log into the Zoom. I'm not sure why, but to be honest with you, I sent the link on the Blackboard. I put it in, I didn't have any Zoom meeting available. I'm not sure why people actually go to Zoom. Maybe they're checking their email. Okay, So I'm going to continue here. This is where it's going to be my office hour. So when we actually try to integrate, so now e, the integration of 2dx is just 2x. Okay, so this is what we call is the integrated factor. So now after we find the integrated factor, now what I want to do, I want to multiply everything by the what we call is the integrated factor. So I come right here, I say, okay, this is e to the 2x, and I'm going to multiply dy over dx plus 2y, and that's equal to, let me just open the parentheses and have it equal e to the negative x, and we close the parentheses. So what we have right now is e to the 2x dy over dx plus e to the 2x times 2y, which equal now e to the 2x times e to the negative x, that leave e to the negative x right here, e to the x right here. Now, what we have right here, if you think about it, this is basically, if you think about it, it's e to the 2x times the function y, e to the 2x times the function y, but if I'm taking the derivative, if you think about the derivative, that should be the function on the top. So e to the 2x times y, when I take the derivative, that's equal e to the x. Now let's go ahead and integrate both sides. So we're going to integrate both sides. So when I integrate both sides, the integration with the derivative, with respect to y, they cancel each other, and we just have e to the x times y. On the other side, the integration with the e to the x is e to the x plus the c. Notice in the integration factor, we did not add the c, but toward the end, we add the c. Now, the minute we finish integration, we divide both sides by e to the 2x. So we're going to divide it by e to the 2x. So we have y is equal e to the negative x, because when you reduce, plus e to the negative 2x and times the c, which is right here. So this will be the general solution for the function, which is we just finished. We're going to look at what we mean by general solution and what we mean by a specific solution. Let's go ahead and do another one where we solve the function using the integrated factor. So let me go ahead and have another example, one of the nicest example we have. So let's see if we can have one. And let me see. So now we have this one. We have example 2. Example 2, I have that, let's see, I'm trying to see that y prime plus x times y, and that's equal x cubed. And this way we will see how this is supposed to be done. So now if we actually find the integrated factor, this will be e to the integration of x dx, which equal e to the x. So we already know that e to the x, and then x has to be squared and then divided by 2. So we found what we call is the integration factor. Remember, again, we will not know c must be added. Now, when we go underneath it and we say it's time to multiply the whole equation by e to the x squared divided by 2, which is will lead to y prime plus xy, which equal x cubed, and that will be e to the x squared over 2 times y prime plus xy e to the x squared divided by 2, and that's equal x cubed e to the x squared divided by 2. Good. So now if you think about what's this on this side, that's y times e to the x squared over 2, but you're taking the derivative of that because that's a product rule, and that stays the same. So now knowing this, I want to integrate both sides, y e to the x squared divided by 2, and you have the prime with respect to y, and that's equal the integration of x cubed e to the x squared over 2 dx. So now in the left side, that's nice, everything cancel out, and you just have this function left. On the right side, we have what we call is integration by parts. So x cubed is your u, and if you take the derivative, that will be 3x squared. If you take the derivative, that will be 6x, 6, and then down to 0. Now, to the x squared over 2, actually, we have to be careful with this. It's possible, maybe if we do it by substitution, it's a bit easier. So if we call u is equal x squared divided by 2, then du will be 2x over 2, which is just x. So be careful with that. That might work a little bit better than the previous one. So now we come back and we say, okay, so if I can write this one as x squared times x e to the x squared divided by 2 dx, because why I wrote it as x squared, look at this one over here, that 2 times u will be equal x squared. So this way we can replace it easily. So that's the integration of 2 times u. Nice. And then now x dx, but this is equal just to x. X dx, that's equal to du. So, and then this is e to the u du. So the minute we make the replacement, now I could see integration by part. I'm going to call tu, and then when I take the derivative, that will be 2. So over here is the derivative, and that will be 0, and over here is the integration. The integration of e to the u is e to the u, and it keep on going e to the u. And now when we do the method of integration, where we keep going in that direction, the first one is positive and the next one is negative. Now when we write it over here, let me just jump to here, e to the x squared over 2 is equal to 2u e to the u plus 2e to the u plus c, where u is x squared over 2. So then y is e to the x squared divided by 2 is equal e x squared over 2, e to the x squared over 2 plus 2e to the x squared over 2, and then you add the c. Now, you can simplify by dividing by whatever you have on the left side, which is your y. So it's very important that you divide under this. You divide not by y. I'm sorry. We're supposed to solve for y. We divide by e to the x squared divided by 2. Let's just simplify this. This is y is equal to cancel each other. So we have x squared. When we divide, this whole thing cancel out, plus 2, because this also x squared over 2 cancel each other out, plus c times e to the negative x squared divided by 2. So that will be the new general solution for the problem which is given on the top. It's just I have to be careful. The first one is a plus right here, but the second one, it should have a minus. So this sign right here is a minus. I hope this is very helpful. Let's see another one. Let's see another one where this time I want to go to a particular solution. I want to go to a particular solution. So let's see if we could actually begin a new page. We're going to say solve the initial value problem. The initial value problem, meaning it's given the problem, but it has a boundary condition. Meaning we have cosine of x times y prime plus sine x times y, which equal cosine to the fifth of x sine x. So now when I look at problem, I said, okay, it's linear, but the problem is this is not 1. Therefore, I'm going to divide each of those terms by cosine by itself. So we have y prime is equal sine x over cosine x times y, which this is a plus sign, and that's equal to cosine. It will reduce to the fourth power of x sine x. That's nice. Now it fits the format I want. This right here will be my b of x, and that right here will be my g of x. So let's go ahead and see if we could actually find what we call is the integrated factor. This is e to the integration of sine x over cosine of x dx. That's not bad. That's u substitution. U equal cosine of x. Du equal negative sine of x dx. So when we integrate, this will be e. This is the integration of negative sine 1 over u du. And the integration of 1 over u, this is e to the negative natural log of u. Okay, now the negative in the front, what it means is you leave ln and you put u to the negative 1. Now e and ln, they are inverse of each other. Therefore, this is just basically u to the negative 1, which equal cosine of x to the negative 1, or another way of saying secant x. So now we find the integrated factor. So what we're going to do, we're going to take secant x, and we'll multiply by the whole equation we have, which is cosine of x times y prime plus sine of x times y, which equal to cosine to the fifth of x sine of x. Now, let's see how we can deal with sine times cosine. That's basically equal to 1. So that's y prime. And this is sine times secant. Secant is 1 over cosine. That will be left as a sine over cosine. Okay, so this is sine x over cosine x, and that's times y. And that's equal to, remember, you're dividing by 1 over cosine. That will lead cosine to the fourth of x sine x. That's when we multiply everything by the secant. Now, if you don't want to write it like this, which is fine, but you have to know like which method I want to write it. I want to write it as this, or by the way, we have to be careful about the entry right here, because I have to follow whatever I simplify at this point right here. So I'm going to take this guy and multiply by secant. So the first one, we have y prime times secant, which is, to write it right here, this will be secant x. Secant x times y prime. The second one, since you have sine x over cosine x times secant x, but cosine is your tangent. So we have right here on the, and actually this is cosine to the fourth when you divide by 1 over cosine, because it is cosine to the fourth. When we multiply by secant, that becomes cosine to the third. Very nice. So I'm just fixing those because I don't want to have a messy number. So okay, this is cosine to the fourth. When you multiply by secant, you reduce the power by 1. So the left side right here, that's nice because that's basically secant x times y. And that's the derivative, and I'll integrate that in a second. And that's equal to the integration of cosine cubed x sine x dx. Now, okay, on the left side, we have secant x times y. Now, what do we have there on this side? This is my u, and that's my du. So your u is equal cosine x, du equals sine x dx. Therefore, when I integrate, this is u to the third du, and u to the third become u to the fourth. The derivative of cosine is negative sign, so I have a negative outside. U to the fourth over 4 plus c, and that's equal secant x times y. Therefore, y is equal negative u to the fourth over 4 times secant x plus c times secant divided also by secant x. Now let's see what's u. U is the cosine. Y is equal negative cosine to the fourth of x divided by 4. But keep in mind, this is basically is the cosine right here. Secant is 1 over cosine of x. And then plus, we can actually make sure this is cosine of x times c. So if you want to keep it that way, that will be also good to handle. So now, a lot of people actually, what they do, they skip all the way to this step, right? They said, since they give me initial condition, I really do not want to work with flipping and doing this and this. So what they do, they say, okay, I can write secant as 1 over cosine of x times y, which equal negative cosine to the fourth of x over 4 plus c. They could see a lot better that they need to multiply the whole entire equation by cosine x. So if we do that, what do we get? Y is equal negative cosine to the fifth of x over 4 plus cosine of x times the c. Let's use our initial condition, the one that says y of 0 is equal to 2. Now, what do we mean by y of 0? At y is equal to 0 at the t or at the x is equal to 0. Plus cosine of 0 times c. Now, cosine of 0 is 1. This is 2 is equal negative. 2 is 2. Hold on. Is it equal? Yes. 2 is equal negative 1/4 plus c. Therefore, c will be equal 2 plus 1/4, which is equal 9 over 4. So we found c. So the minute you find c, then you found whatever your equation will become. This is negative cosine to the fifth x over 4 plus 9/4 cosine x. So we found this is called particular solution. We don't have any more c, therefore this is called particular solution. We'll do another one on the integration factor, and then we'll try to do something a little bit different. So now let's look and see if the question right here will say, just find the integrated factor, find the integrated factor. Okay, so if I want to find the integrated factor, and let's see, the problem is, let's see if we can have, 1 over t plus 1 cubed and y prime plus minus 3 divided by t plus 1 to the fourth power, and that's equal t divided by t plus 1 to the fourth power. Remember, the idea here is we want to find the integrated factor. So this coefficient right here in the front must be 1. Therefore, I'm going to go ahead and multiply the whole entire equation by t plus 1 to the third. So if we do that, let's see what happened. That will become a y prime. This become 3, but when you have 3 up and 4 down, then you're left with t plus 1 and the y right here, and that's equal. Now we have 3 up and 3 down. then we have over t plus 1. Now, what is our integrated factor come from? My b is right here. Therefore, e to the integration of negative 3 divided by t plus 1 dt, and that will become e to the negative 3 times the natural log of t plus 1. And the negative 3 goes on the top of the parentheses, t plus 1 to the negative 3. E and ln cancel each other, therefore this is t plus 1 to the negative 3, or 1 over t plus 1 to the third. I hope this is very helpful, and